The most anticipated stellar death of our time is when the giant star Betelgeuse transforms into an explosive supernova. When this occurs, it will shine as brightly as the full moon and even be visible in daylight. Unfortunately, we do not know exactly when this dramatic event will take place. After Betelgeuse was almost pronounced dead due to mysterious fluctuations in brightness, it eventually recovered, until now. Once again, Betelgeuse is attracting attention with unusual displays of light, and a new study suggests that Orion's shoulder star could explode much earlier than expected. In 2019 and 2020, excitement surrounding Betelgeuse was boundless. The giant star made headlines with a drastic loss of brightness, which some experts interpreted as a harbinger of an impending supernova. There is no doubt that the explosion of this gigantic celestial body will be an overwhelming spectacle. The red supergiant, only 650 light-years away, is 800 times the diameter of the Sun and already shines 10,000 times brighter in visible light. As one of the brightest stars in the night sky, Betelgeuse's sudden dimming in October 2019 was particularly perplexing. Normally, its luminosity is estimated to be between 0.3 and 0.4 magnitudes. To put this in context, magnitude mag measures the apparent brightness of a star, with lower values indicating greater brightness. When Betelgeuse dimmed, researchers recorded a drop in brightness down to 1.1289 mag, while its temperature dropped by about 100 degrees Celsius. The decrease was so significant that it was visible to the naked eye, causing Betelgeuse to fall to 21st place on the nightly star chart. Astronomers associate such dramatic dimming with an imminent supernova because the Orion shoulder star has reached the final stage of its development as a red supergiant, which inevitably ends in a powerful explosion. This can be signaled by strong expansion combined with a decrease in brightness. However, this remains uncertain because precise observations of supernovae before their explosions are lacking. We also do not know if such dimming occurs years before a supernova or just hours before. What we do know is that Betelgeuse has not yet disappeared from the cosmic scene, which would have been noticeable. Experts predict that when Betelgeuse does explode, it will shine as brightly as the full moon for weeks. The dying colossus would be so bright that it would overshadow other stars in its vicinity. As the brightest and closest supernova in recorded history, it would even be visible in daylight. The most significant drop in brightness in the last 2 years has raised new questions. If the dimming 5 years ago was not linked to a final explosion, what caused it? Observations with the Hubble Space Telescope suggest that a massive plasma eruption created a dust cloud that darkened the star by nearly 2/3. While Betelgeuse regularly ejects stellar material, this event was unusually strong, 2 to 3 times more powerful than normal, resulting in a mass loss 30 million times greater than that of the Sun. Although Betelgeuse returned to its original brightness, it has since exhibited further unusual variations. In 2023, the star shone significantly brighter than average before losing a drastic amount of luminosity again a few months ago. Although not as extreme as the 2019 to 2020 dimming, researchers recorded the lowest luminosity in 2 years. This again raises the question of whether Betelgeuse is on the verge of exploding. The answer remains uncertain. No expert can say with absolute certainty whether the giant star will explode tomorrow or in a million years. It is even possible that Betelgeuse has already exploded and the light has simply not yet reached us. A 2023 study suggests that Betelgeuse may explode much sooner than previously thought. Researchers from Japan's Tohoku University in Sendai examined the star's pulsations and uncovered surprising evidence that it may be much older than assumed. Betelgeuse's outer layers pulse, leading to regular brightness variations, with the most prominent cycles lasting 2,200 and 420 days. Until now, astronomers interpreted the shorter interval as the star's heartbeat, indicating a younger celestial body. However, if the 2,200-day period represents the true stellar pulse, then Betelgeuse is even larger than previously believed. Instead of being 800 times the Sun's diameter, it may be 1,200 times larger. This would also mean it is further along in its life cycle, bringing its supernova much closer. Stars shine by fusing hydrogen into helium, and as they age, helium is fused into carbon, followed by heavier elements. Japanese researchers use computer simulations to model how bright stars evolve from birth to their final stages, revealing that Betelgeuse has already reached the carbon-burning phase. Once carbon is depleted, a core collapse leading to a supernova occurs within decades. However, the study could not precisely determine the expected explosion date, estimating it could happen in less than a few hundred years. This is significantly sooner than previous predictions, which suggested Betelgeuse's supernova was still 100,000 years away. However, not all experts agree with this conclusion. Astrophysicist Morgan McLeod, for example, argues that the new interpretation does not align with other studies of the star. If Betelgeuse's main pulsation cycle is indeed 2,200 days, then the star would be too large to match existing models. In addition to these uncertainties, new analyses suggest that Betelgeuse may have a previously undetected companion star. The longer 2,200-day brightness fluctuation has become the focus of astronomical interest. A recent re-evaluation by researchers from the Flatiron Institute in New York found anomalies in Betelgeuse's light curve that do not match known causes like rotation, magnetic fields, or convection currents. The only plausible explanation left is the presence of a smaller companion star. If this is true, the periodic fluctuations in Betelgeuse's brightness reflect the orbit of this hidden partner. When the companion star moves behind Betelgeuse from our perspective, the star appears dimmer, and when it moves beside it, the combined brightness increases. This companion star could also influence the distribution of dust clouds around Betelgeuse, playing a role in its unpredictable brightness changes. But why has this companion star remained undiscovered for so long? The most likely explanation is its low mass. Experts estimate it weighs only 1.7 solar masses, making it nearly 12 times lighter than Betelgeuse. Furthermore, it is thought to orbit Betelgeuse at a close distance, just 2.43 times Betelgeuse's radius, meaning it is literally outshone by the giant star's brilliance. The pulsations and brightness variations of Betelgeuse have also made it difficult to detect this stellar companion. However, complicated does not mean impossible. Researchers now hope to use large telescopes to confirm the companion's existence and determine what type of star it is. The mysteries of Betelgeuse continue to captivate astronomers, and new discoveries could reshape our understanding of its future. Whether its supernova is imminent or centuries away, one thing is certain. When Betelgeuse finally explodes, it will be one of the most spectacular astronomical events ever witnessed by humanity. Beyond the mystery of its pulsations and the possible existence of a companion star, Betelgeuse remains a cosmic enigma that continues to challenge our understanding of stellar evolution. If the red supergiant is indeed nearing the end of its life cycle, its eventual explosion will provide an unprecedented opportunity for astronomers to study a supernova in real time. Unlike past supernovae that were only observed after their explosions, Betelgeuse's proximity to Earth offers scientists the rare chance to monitor the final stages of a dying star before it reaches its dramatic conclusion. When Betelgeuse finally explodes, the impact on astronomy will be profound. The massive release of energy will generate an intense burst of neutrinos and gravitational waves, which will be detected by observatories worldwide. The supernova's light will take a few hours to reach Earth, illuminating the night sky with a brilliance comparable to a full moon for several weeks. The explosion will also result in the formation of a neutron star or possibly a black hole, depending on the exact mass of Betelgeuse's core at the time of collapse. However, despite the spectacular nature of this event, there is no cause for concern. At a distance of approximately 650 light-years, Betelgeuse is far enough from Earth that its explosion will not pose a threat. The supernova's radiation, including the potentially harmful gamma rays, will dissipate over vast distances before reaching our planet. Instead, its demise will serve as an extraordinary scientific event, offering insights into the life cycles of massive stars, the formation of elements essential for life, and the behavior of cosmic explosions. While the exact timing of Betelgeuse's supernova remains uncertain, ongoing observations will continue to track its changes in brightness, temperature, and spectral properties. Scientists will use powerful telescopes, including the James Webb Space Telescope, to analyze its structure and monitor any further signs of instability. Future missions may even provide direct imaging of the star's surface, offering a clearer picture of the forces at play in its final moments. For now, Betelgeuse remains an object of fascination, a celestial time bomb whose explosion could occur within our lifetimes, or remain a distant event for future generations to witness. Until then, astronomers and stargazers alike will continue to watch Orion's shoulder, waiting for the moment when one of the most famous stars in the night sky finally meets its fiery end.